Hi everyone, I am Anaka R of S7 ECB. Now I am going to do a seminar presentation on the topic Holographic Technology under the guidance of Assistant Professor Sunita S. Pillai. In usual photography, we only get to see the two-dimensional images of objects. So, holography is a developing technology which helps us to get a more realistic view of objects. The contents are introduction, history, hologram, laser, working, types of hologram, rainbow hologram, digital holography, companies involved, current developments, advantages, disadvantages, conclusion, and references. Introduction. Holography is a fascinating technology that allows us to capture and recreate three-dimensional images. It records both intensity and phase of light waves. This is a method of creating a unique photographic image without the use of lens. Therefore, it is also known as lensless photography. Nowadays, virtual reality platforms have emerged to support socialization among users through shared environments. This gives a more realistic experience to users in the form of holo meetings and holo conferences. After several years of experience with video calls on smartphones and tablets, many users report that they are eagerly awaiting the chance to meet others digitally using immersive communication services such as a 3D holographic augmented reality calls. Compared with flat screen video, holographic communication can convey a sense of presence that enhances the quality of human interaction. Holography is based on the concept of interference and diffraction of light waves. It provides complete information about a wavefront. Now, looking into the history of holography, the basic concept of holography was invented by Dr. Dennis Gabor in the year 1947, and he also won a Nobel Prize for it in 1971. In 1962, first practical holograms that recorded 3D objects were developed. In 1989, diffractive holographic elements were used due to the advantage they offer over usual refractive and reflective counterparts. In 1991, white display holograms were recorded by employing flexible fiber optic beam delivery systems. In 1997, multicolor 3D hologram with a large perspective was demonstrated. It can be stored and reproduced using a photorefractive crystal. In 2000, it led to the advent of wearable display so light that you can forget that you are actually wearing it. During this time, a haptic display with a head-mounted projector was developed. In 2004, a system which can be used for real-time recording, data transmission and reconstruction of 3D objects were developed. In 2008, experimental investigation was done on holographic three-dimensional TV approach. In 2010, it led to the development of holographic stereoscopic display that does not require the wearing of special eyewear. In 2013, optical fiber based large scale holographic display with a pupil tracking technique for wide viewing angle was developed. In 2018, noise filtering methods for 3D display was introduced. In 2020, pixelated blazed gratings was used for high brightness. In 2021, it led to the development of lunar face learning system to assist students in learning concepts of lunar phases. In 2022, curved holograms were generated using bidirectional phase compensation. This can enlarge central angle of the curved hologram twice as that of one directional phase compensation. In 2023, holographic display with gesture control is being developed. Now let us look into what a hologram is. Energy is the only way of connection between creatures and the external world. This energy contains data and information of the world. Without this medium, human does not have any method to understand the universe. Electromagnetic waves are one of the most important conveyors of energy. Color is an important information which is being carried by the electromagnetic waves. Electromagnetic waves are generated when a material's atomic structure is disturbed. White light or VIBGYOR is that part of the electromagnetic spectrum that is visible to human eye. Photonic crystal is an optical nanostructure whose refractive index changes periodically and gives rise to diffraction. They reflect only a band of wavelength depending on the material on which light is falling. For example, apple has red color as red is reflected by it and all other colors are absorbed by it. Photonic crystals can store information such as light field, phase information, amplitude information, etc. Usually, when we take photograph of an object, the camera records the light that is being bounced off from the object and then goes into the camera's lens. But this only records a single perspective of the object, and that's why the image looks flat, just as shown in figure in first figure. To get a three-dimensional view, we could take two images of the object and then set one of the image to one eye and the other image to other eye. It gives more depth to the image, but it still has a problem. That is, we can't turn our head and get more perspective of the object. Light is a wave which is made up of electric and magnetic fields. We can deflect light by passing it through a diffraction grating. The finer the grating, more the light wave is deflected. We can combine a bunch of gratings in order to shape the light wave. That's what a hologram is. It is a combination or superposition of diffraction gratings that are used to reconstruct the original light wave that bounced off the object. In order to make a hologram, we have to take the light that is being bounced off from the object and then mix it with a laser beam. Then they will form an interference pattern. Similarly, when we drop two pebbles into a pond, the waves spread out and then they meet each other to form a sort of interference pattern. We are going to take this interference pattern and then put it into some photosensitive chemicals that will record it. Thus, a hologram is formed. Hologram is just a photograph of all interference pattern. Photograph shows only height and width of an object, while holograms show height, width, and depth of an object. Peacock feathers can act as a natural hologram as light is diffracted by it and wavelength is automatically selected. Holography is the process of making holograms. It is an advanced photography that allows an object to be recorded in three dimensions. It is used to store, retrieve, and process information. Interference of laser beams are used in holographic technique. Laser stands for light amplification by stimulated emission of radiation. For example, if thousands of people of different age groups are sitting in a room and they are talking out different things, we will feel as if it is a very disturbing kind of noise. But instead, if they all sing the same note of a song, it would appear as a loud note with a single frequency. This is exactly the reason for using laser, which is monochromatic and coherent. That is, they have only a single frequency and constant phase difference. Now looking into the working of hologram. The components that is required for the holographic process are laser beam source, beam splitter, photographic plate, mirror and object. For recording a hologram, the laser beam is split into two beams, that is, the object beam and the reference beam using a beam splitter. The object beam is expanded and it is then used to illuminate the object. Then light is scattered by the object, which then falls on a particular plane known as the holographic plane. The reference beam is expanded and it then directly falls into this holographic plane. Both these beams interfere with each other and then create an interference pattern of bright and dark fringes. When these fringes become stable, hologram is developed. In order to view the hologram, we have to re-illuminate the recorded hologram using the same beam of laser. After reconstruction, a diffraction pattern is formed in the hologram. In some direction, we get maxima due to constructive interference, and in some direction, we get minima due to destructive interference. In order to get the 3D image, the observer has to see it along the direction in which maxima is obtained. By tilting the image slightly, the details of the object can be seen. Thus, 3D image is formed. There are mainly two types of holograms, that is, transmission hologram and reflection hologram. In transmission holograms, the arrangement is such that the object beam and the reference beam approach the holographic plate from same side. The interference fringes are generally perpendicular to the surface of the recording material. When such a hologram is reconstructed, Then reference beam and object beam lie on opposite sides of the hologram. Next is reflection hologram. In reflection holograms, the arrangement is such that the reference beam and the object beam approach the holographic plate from two opposite sides. The interference fringes are usually parallel to the surface of the recording medium. When such a hologram is reconstructed, then the reference beam and object beam lie on the same side of the hologram. Rainbow hologram. In usual holograms, laser beam is used, but with the advancement in technology, it has been possible to construct holograms using white light instead of lasers. They are called rainbow holograms. These are made by a double holographic process. An ordinary transmission hologram is used as the object and the second hologram is made through a slit. The slit process removes the coherence requirement of the viewing light and hence 3D object could be viewed using white light. The horizontal slit also removes the vertical perspective of the original hologram and retains 3D character only when eyes are moved horizontally. For recording a rainbow hologram, the object is illuminated with white light and an image is formed in the plane of the hologram. This is the object beam. Then a narrow horizontal slit is placed between the object and the lens. The hologram plate is also illuminated with a reference beam derived from the same laser source. The interference pattern between reference and object beam is recorded. In order to view the hologram is again re-illuminated by the same light source, which is the reference beam. A reconstructed image can be seen by the observer at the right of the hologram. However, this image will appear as if it is being viewed through a reconstructed slit to the right of the plate. This means only a small horizontal section of the image can be seen from any one location. If the observer changes the viewing position, a different part of the object can be seen. When the hologram is illuminated with a white light source, each color reconstructs different part of the image at a slightly different angle so that the whole object is now seen, but with color varying in the vertical direction. If eyes moves vertically, no 3D image can be seen, only rainbow color. These holograms are used in practical applications such as credit cards, quality merchandise, etc. We may have tried different virtual reality headsets, and while the experience was exciting, after a short period of time, we may have developed a headache. This is because in this, two images of an object is taken and one of them is projected to each eye. To create the perception of depth, the images overlap in such a way that your eyes converges to an artificial depth plane. But it still remains focused at a further distance called focal plane. So, our brain gets confused regarding where to focus. If we try holding our image with our hand, our eyes will focus on our hand and background image will be blurred and we will have to take off the headset. So we use digital holography where multiple depth planes and multiple distances are created simultaneously. So we can now enter into a world of realistic 3D environments. This reduces strain of our eyes and brain as we have a long lasting image. Some of the companies which are involved in the holographic technology are Lightfield Lab, which was found in USA in 2017. They make display devices for holographic experiences. They also provide integrated processing and imaging solutions for delivery over commercial network speeds. Next one is Wave Optics, which was found in UK in 2014. Wave Optics is a developer of a patented technology based on waveguides for projected display applications. They claim optical design harnesses waveguide hologram physics and photonic crystals rather than conventional augmented reality projection. Next one is Tilt 5, which was found in USA in 2017. They provide an AR glass which works as a holographic projector. Next one is Looking Glass Factory, which was found in USA in 2013. They provide volumetric three-dimensional display solutions. They also offers a plugin called Unity that enables the creation of applications in the volume called HoloFlix, which resemble holographic volumetric videos. It enables users to see and touch digital 3D content in the real physical world without headsets. Next one is Real View Imaging, which was found in Israel in 2008. They provide interactive three-dimensional holographic display-based solutions for medical imaging applications. Their solutions find applications in clinical fields and complex surgical procedures. Some of the current developments in this technology include three-dimensional holograms with gesture control, which is being developed using augmented reality. Also, this display can be controlled with our fingertips. This covers sectors of education, medical imaging, etc., with good effects and cheap cost. Rapid generation of physical holograms based on light fields is also being developed. This is done by combining light field with holographic display and the use light field image combined with deep learning algorithm to generate physical hologram quickly. Aiming at the problem of low resolution of light field subimages, the super resolution algorithm is used to improve the resolution, and then depth estimation algorithm is used to estimate the corresponding depth information, and a pair of RGBD images are input to the neural network to generate holograms. Real-time high-quality computer-generated holograms is being developed using complex valued convolutional neural network. Holographic displays are ideal display technologies for virtual and augmented reality. However, real-time high-quality displays are difficult to achieve because the generation of high quality computer generated hologram is inefficient in existing algorithms. Therefore, complex valued convolutional neural networks are used. Holobeam, which is thin near eye displays, is being developed. They provide an alternative to conventional augmented reality glasses. These beaming displays remove active components such as batteries and electronics from AR glasses and move them to a projector that projects images to user from a distance where users wear only passive optical eyepieces. However, earlier implementations of these displays delivered poor resolutions without any optical focus. So, a new milestone for beaming displays known as hollow beam is used. In this new design, a custom holographic projector populates a micro volume located at some distance with multiple planes of images. Users view magnified copies of these images from the small volume with the help of an eyepiece that is either a holographic optical element or a set of lenses. Now let us look into some of the advantages of this technology. Holography gives a three-dimensional realistic view as phase of wavefront is also recorded, while in conventional photography, only intensity is recorded. It also does not require use of any special glasses or projection screen. It is also being used in the area of telecommunication. The telecom industry has been actively working to provide a holographic video calling experience. It can also be implemented in 5G technology. It has medical applications as the internal body parts such as liver, brain, heart, etc. can be viewed. This can be used by doctors as well as medical students. This is used for advertising and marketing in order to show the detailed view of their products to customers. This can also be used for security and storage applications. It is used for security because the hologram will have no resemblance to original image. It is only densely packed fringes. By looking at hologram using naked eye, we cannot see anything. The hologram needs to be reconstructed to view three-dimensional object, which is a sensitive or difficult process. Therefore, duplication is difficult. In a photographic plate, only single image can be stored, but in hologram, several images can be recorded, and therefore it is also used for storage applications. It is also used in military to get a clear map of the surgical location, and this can also be used in the field of education as it helps students to explore and interact with holographic images. Some of the disadvantages of this technology are the limited viewing angle. That is, many holographic displays are designed to be viewed from specific angle, which means people viewing from other angle won't get a clear image. And then it is also expensive and it is also not easily seen in the presence of fluorescent light. Energy consumption also depends on various factors such as display technology, size of display, operating mode, power source, etc. In conclusion, the future of holographic technology is surely bright. It has endless applications, as far as the human mind can imagine. It gives more realistic method for communication and entertainment. We can surely expect this technology to become more common in our everyday life. These are my references. Thank you.